Okay, hopefully we keep everybody awake here. So, first couple of questions. Anybody from California? No? West Coast, anywhere? Southwestern United States, Arizona, Utah, Nevada, New Mexico.
Oh my gosh.
Nowhere. All right. Has anybody heard about what's going on in California with the drought? Okay, vaguely. The Middlebury bubble is still a little bit, I know. Sometimes it's hard to know what's going on. So, here's what my plan is, right? I've been working for the last year on the California drought. So that's what I'm going to talk to you guys about today. And the intention with doing sort of a deep dive into this use case is really to get a chance to look at some of the factors that Bill mentioned, right? Policy, politics, budget, partnership, all of these different things, and take a very detailed look at how they play out in one use case. And then we'll look at a bunch of other use cases along the way, but we want to kind of use this to pull apart all of those different themes that we see with geospatial technologies. So that's what we're going to try to do today. And then we're at the end, we'll kind of bring it full circle and sort of zoom out. That's one of my favorite terms, like zoom in, zoom out, and figure out what context this has in the greater geospatial industry. So this is where I like to start. California drought, how bad is it really? And what I like about this slide is that probably the most impactful messaging that came out of the last 2 years about how bad the drought really was came from a cartographer. So this was an LA Times graphic designer who made a series of, actually I think it's up to like 200 something maps. It was originally published with 169 maps. About how bad the drought was really, and it actually sort of, I don't want to say went viral, but it essentially went viral. This is the whole series of them. This is where we start, 2011, okay, and I'm just going to show us the legend really quickly. Abnormally dry to exceptional drought, 2011, and this is the drought series map that he made. And it's been published, republished, and shared to the extent that when it was published earlier in 2015, you can see where we are here. Pretty scary, right? He actually has continued to keep it up to date. So it was originally published sometime in here, but it's been a resource. It's been a resource for folks looking at the drought, and it's pretty obvious why, right? And this is something I don't need to tell a bunch of GIS people, that the visual impact of this type of messaging says a lot more than sometimes the written word about how serious the situation is. So that's just a great little anecdote to start off with. So we have this set of maps. 2014-2015 was the driest year on record in California since they started keeping records in 1895. So that's pretty bad. The snowpack, which accounts for about 30% of California's water supply just through runoff, was at an all-time low. I don't know if anybody saw the very sad pictures of the Sierras last winter. Are there any skiers in the class? Hopefully a few. Yeah, me too. It was very, very sad. So here we are. Here's our nice little number here, 5%, 2015. So the snowpack's at an all-time low. And basically what happened, I'm going to show one more graphic here, is this. I like this too, because this sort of puts into perspective how we measure water sourcing in California. So each of these little bars represents one of the reservoirs, one of the major reservoirs, and you can see the blue number is the percent of total capacity, and the red number is percent of historical average. So generally just another sad picture about how little water was available. And actually someone came out, one of the NASA Jet Propulsion Laboratory guys that studies this regularly came out in the spring and really scared everybody and said California only has 1 year of water left. And he had to sort of redact the way he said that. And we have 1 year of ground stored water left should it never rain again. So he really freaked everybody out saying that. But that was just to reflect truly how little water there really was. So what happened? April 1st, 2015, big day in the water world, California especially. Governor Brown issued an executive order saying that the state had to cut 25% mandatory conservation cuts. So in 2010, there was already an order in place, a legislative agreement that basically said the state would work to conserve 20% of to save 20% of their current water use by the year 2020. It was called 20 by 2020, catchy. This was a little bit different, mandated. So it was an executive order. It was mandated, and it upped the reduction to 25%, and it was 25% compared to 2013 usage. So it wasn't like generally 25%. It was against pretty much right now, in the last year, you got to cut a quarter of your water usage. This is a clip from the New York Times, just saying that basically Governor Brown ordered this mandatory reduction for the first time in California's history. So this made a lot of headlines. And he actually made this announcement very dramatically while standing in a field that had no snow in it, which is where they take every month or so, they take the annual snowpack record. And it was the first year on record that they had no snow in this particular field where they usually take the snowpack record. What I want to just read here really quickly. Mr. Brown, in an executive order, directed the State Resources Control Board, they're an entity I'll talk more about, to impose a 25% reduction on the state's 400 local water supply agencies, which serve 90% of California residents. This is critical. The agencies will be responsible for coming up with restrictions to cut back on water use for monitoring compliance. State officials said the order would impose varying degrees of cutbacks on water use across the board, affecting homeowners, ag, business, golf courses, the whole 9 yards. So the important part about this, they're imposing these regulations, and that there's 400 water supply agencies, and it's up to each of those agencies to figure out how to meet this new regulatory demand. So basically, April 2nd in California was bedlam, like just total chaos. And these were some of the titles there. Yeah, a lot of big news and some pretty scary pictures. You can see reservoirs way down, and obviously poor snowboarder there having a pretty rough season. So this is an interesting map the New York Times came out with afterwards. I should share the link so you guys can check it out. Again, mapping, making an impact here. So they've got 3 different ways that you can look at this. Change in consumption is not my favorite. Daily gallons per capita is. So in the water world, the way that we talk about water and water usage is GPCD, or gallons per capita daily. So that will go on our terminology sheet. So gallons per capita daily is basically saying how much water do you as a human being use on a daily basis. And so what we're able to see here is folks that are below the state average are blue, and above the average. And let's also remember, the average just means if everyone was overusing for the whole year, the average is still potentially high. The average doesn't really tell us a lot about how much we could save. It just tells us where we are compared to other people who probably also waste water. So as we come down here, we can see some really big problem areas. LA, the Coachella Valley. I don't know if folks, we're going in the dark. It's like we're not even here anymore. So we can see, and it's also very dynamic, which is kind of cool. You can zoom in and check it all out. But so we've got certain communities. Beverly Hills has come under a lot of scrutiny. I'm going to pass you guys an interesting article. Beverly Hills Public Agency, just fun fact, will not tell you who their water conservation staff are. You cannot talk to them. You cannot get in touch with them because they're just getting hammered by the national media. So, which is, their public agency. So obviously they should be sharing who their staff are. But so we can take a look very clearly at places where we have some efficiency. Actually, there's some incredibly efficient towns down here, but then there's some water wasters. So we'll talk a little bit more about why that is.
That's consumption.
That's consumption. Yeah, that's actual against an average.
Agricultural consumption.
No. Yeah, and then we do have to split those things out. So a couple other fun facts. So there was a major push at this time after April 1 for conservation programs, right? All these agencies kind of had to scramble to find the funding, which the state began to provide slowly but surely. One agency that I'll talk a little bit more about actually spent $500 million with a B dollars on buying turf grass. So they provided $500 million. It was supposed to be a $100 million project when it started, $86 million when it started. And they provided money to Californians, average citizens, basically through their water agencies, and they would pay you to replace your lawn, get rid of your lawn. So $500 million, probably not money well spent between you and I and them. They know that.
Wait.
But
They gave turf grass? Wouldn't that just die again?
No, to rip it out and replace it with not grass.
Oh, I see.
Yeah, so to get rid of it for good. Yeah, most of the time replacing it with California native landscaping or something like that. But the problem was once they started the program, it was a PR thing, and they couldn't really pull back and tell people, oh, no, we're not going to pay for your lawn. So it turned into a $500 million issue, and they actually don't think it made very big impact, right? So if you want to stop people from using water, or you want to cut back on water use, you can't buy every blade of grass in Southern California. It's not really a realistic thing. But that's, that's what happened. So $500 million. In the meantime, we had farmers that had to pump 80 to 100% more in terms of groundwater than they used to, which is a lot. And what started to happen, has anybody heard about this? The ground has started to sink in California. They're having issues with what we call subsidence. So it actually means that they're pumping so much from the underground aquifers that are not being replaced that hundreds of miles at a time are slowly just sinking. Very scary stuff, and there's an article or two that I have in the optional reading that talks a little bit about subsidence, but in some places almost 2 inches a month, and that's because these aquifers aren't being replenished. So ag, if anybody's heard about this, ags come under a lot of scrutiny, but that's a problem that involves a lot of complex systems, right? So ag, when we talk about agriculture, it also involves, we're talking about economic impact nationwide and even globally. So we talk about agricultural water use, we have to consider a whole sort of different set of factors. So here's kind of what I wanted to discuss really quickly. So I know you guys don't know a ton about the drought, but what do we think, who do we think the stakeholders would be when it comes to the California drought? I just want to brainstorm a little bit. So who has what we're going to call stakeholders, folks that have a vested interest in the outcome of this particular scenario. In this case, it can be an individual, an organization, or an entity, and they have some vested interest in the outcome. Who do we think those people are? Let's just brainstorm.
And can the outcome be, can we consider the solution as a part of the outcome?
Yeah.
So if you have to buy a whole bunch of new water pipes, does that?
Yeah, then you would have then the person who sells those pipes and the person who's buying those pipes probably have a vested interest in meeting them in the first place, right? So who do we think has a vested interest in how we manage the California drought?
Agriculture.
Mm-hmm. And we got to remember this can be split into we call growers, which are like big ag, meaning they actually own individual farms. So we have growers, we have farmers. Start there. Who else?
Residents.
Mm-hmm. Residents, I like to call them consumers because they're consuming water, right? Who else? Yeah. Private companies. What kinds of private companies? So private sector, definitely, yeah. What kind of private companies care about the drought? Mm-hmm. So if you do desal, you're like infrastructure, contracting. Who else? Yeah.
Rely on tourism, like ski areas.
Yeah, that's true. I didn't think of that. That's a good one. Yeah, just shout them out. Keep going.
Food industry.
True. Food we can kind of put either place. I'm going to put them up here, but I could see them going another place. Keep going. Who else? We got a couple big ones we haven't even gotten near.
Local governments.
Yeah, government. Yay, my favorite one. Okay. When we say local government, what are we thinking?
Towns or counties.
Okay. Go a little bit further. Who at the town or county cares about this? There's a couple people, and I've kind of put them in different categories. No, that's all right. So, government, if you're working for a city, you might have one of many different jobs. You might be a politician, so you're actually a representative, and that's maybe what you're thinking. So I would say we've got politicians. Oops, can't spell. That's an A, terrible A. But then the government also, we could mean the actual utility themselves, right? Is that where you were headed? So this is probably the biggest one, water agencies. And a lot of times those are local government-owned agencies. The reason I split these guys out, and I actually almost would put a third one here, which is policymakers, because a lot of times the people that are representing folks, sometimes they're voting on policy, but not always. We'll talk a little bit more about that. Who else might we have? Anybody else? Just go to my list. Any other ideas?
Other,
Okay, we got a lot of them. So I said, yeah, public citizens, farmers, growers, ag, policymakers, because when I think policymakers, I'm thinking about the State Water Resources Control Board. So they're government. They're not elected officials. They're not the same as politicians, right? Water retail and wholesale agencies, there's a difference, but they are both in the business of selling water. Private sector water companies, so in California, it's kind of the wild, wild west. There are actually water companies that are public, and there's water companies that are private, and they operate totally differently. And then we have private sector water consumers, so we didn't really hit on this, but Anheuser-Busch, for instance, they use a lot of water, okay? So they care about how much their water is going to cost them when they're buying it. Other drought states, so I guarantee you that all of these same interests in Arizona are watching very carefully what's happening in California. They all share rights to the Colorado River, so they care a lot about how California is using their water. The legal industry. So many of the decisions on water policy are being decided, if they become really contentious, in the courts. And then the actual justice system and the lawyers that support those decisions have to deal with the legacy of whatever is being decided today, right? The energy sector. So here's a fun fact. 19% of the energy in California is spent pumping water and delivering water from one side of the state to the other. 19%. So when we talk about energy efficiency, you can't really make a dent in it if you're transferring water from the top of California to the bottom. Contracting and construction, absolutely. Major infrastructure projects are huge, hugely expensive because, like I just said, we're pumping water from one side of California to the other, and we're also taking on big projects like desalination. Conservationists, so we didn't talk about this, but obviously we're in a drought, so the first thing people like to talk about is conservation. We got to save water, so there's a serious sustainability issue there. Finally, scientists. So NASA contributes a lot of data. They're located in, they've got JPL is in Pasadena, and they contribute a lot to the conversation in terms of what data is out there available to study and make use of when we're confronting this problem. And then politicians, so that representatives that actually have to represent what the public thinks. All right, whew, that's a lot. So how do all these players interact? We talked a little bit about the hierarchy here. I'm just going to switch over. I think I got it. Okay, does anybody use Prezi? Yeah? Oh, it's kind of new to me, so I'm not that great at it, but it's pretty awesome if I can get it to work. So yeah, I just want to go through really quickly the hierarchy a little bit, and I know this is a lot of like terminology, mumbo jumbo, but I think we'll make some use of it. So I want to talk a little bit about supply, how supply moves through a hierarchy, and then how funding moves through a hierarchy. So the two things that we really care about the most. So first of all, at the top of the hierarchy here, we have the federal government. There are a couple agencies in California that we care about, not that we don't care about the rest, but the EPA, they do all the water quality control, and the Bureau of Reclamations, and they handle a lot of the water rights and supply disputes. State of California. So State of California owns 25% of the state's water rights, and they focus a lot on supply planning, demand forecasting, and the big infrastructure. So when you talked about desal, which is a great point, they are involved in a lot of those big infrastructure projects. And we have with the state, oh, I'm sorry, I didn't get this right. So we have two major agencies we care about at the state level. CADWR at the top, and they handle the supply piece of it, and that stands for Department of Water Resources. And then the State Water Resources Control Board, they were the ones mentioned in that article by the New York Times. And those guys are the bad guys, basically. They get tasked with pissing everybody off because they are in charge of regulating all of this. So when the governor of California says we got to cut 25% of our water, he walks away, he's done. The state board has to figure out how to go out and actually enforce that. And it can get pretty contentious, we'll say that, and we'll get into that a little bit more. Any questions on that? Nothing? Yeah. Yeah, I can share them, absolutely. Okay, so down the pipeline from there, so let's say the state owns a whole chunk of water. Next, we have regional wholesalers, and I'm going to make that actually singular. We have a regional wholesaler. There's one, Metropolitan Water of Southern California, known as MWD, Metropolitan Water District. You guys will have a few readings about them tonight. You'll get a sense of kind of what they do, but they are huge. They supply all the water to all the retail agencies for all of Southern California. So actually 1 in like 19 or 20 Americans gets their water from this company. That's how many people are living in Southern California, which is pretty amazing. Over half of the supplies that they supply, meaning water, that they deliver comes from upstate, from the Department of Water Resources, and the other half comes from sources on the Colorado River, which they also own a large chunk of the water rights. And we do care about how much they charge for water, because that cost is then passed down to the retail agencies and then the consumers. So just to make things more confusing in California, we then have regular wholesalers who buy all of their water from the one regional wholesaler, MWD. And I've got some examples there, but we're actually, so tomorrow Bob Tincher is going to be speaking with us. He is the basically the resource manager, director, what's his actual title? He's the water resource manager for all of San Bernardino County, and so he's a wholesaler, which means he sells water to the local guys, the local retail agencies, which is typically the city, but could also be a smaller private agency. They vary in size. So LA, for instance, huge, but they're still a retail agency.
They're still local, considered local.
I would say maybe a fairer description there is retail, which means retail means you're then providing it to an individual, to homes and businesses. So that's just a quick sample of, and sometimes really when it's really crazy, a wholesaler can also be a retailer, but we won't get too into that. I'm just going to jump down the line really quick here. So in terms of supply, we talked a little bit about a couple of these things. Oh, come on, Prezi. So water supply. We get water from a couple of different places. If it's imported is where a lot of Southern California's water is imported. It comes from the state. It comes from federal, and there's basically two big pipelines. One is the State Water Project pipeline, and one is the CVP. And so those provide a lot of the imported water to Southern California. And then there's local sources. So that could be desalination. It could be gray water or reused, recycled water. And sometimes there's even local supplies. So actually San Diego County, even though they're further south, has enough water right now. And they're mad that everybody upstream from them is using it before it gets to them. We've got groundwater supply. If you're in Northern California, you don't deal with any of this. You don't have a wholesaler. You just have groundwater. You've got water in your backyard because you're not in Southern California in the desert. And then we mentioned these big infrastructure projects that can also be a source of supply. So that's kind of an overview of those major supply sources. Questions on that? Yeah.
You know, like percentages of how much is gray water, how much is desalinated, how much is imported?
It depends. For absolutely every agency, the answer is going to be different. So every agency gets a different distribution of their own supply. So their supply might be 100% groundwater, it might be 0% groundwater. It might be mostly imported with some recycled reuse, diversifying their supply. But it's absolutely different for all 400 of them. Thus the chaos.
Is that
Yeah, but that's a great question. All right, I'm going to skip out of this really quickly. Okay. So, sorry, we're going to skip to this guy. So this is a little different way of looking at this. So if we have, oh no, don't do that. If we have our supply chain here, okay, so here's one scenario. This is illustrating this exact point that you just talked about, right? In the first scenario, I'm a homeowner and I get my water from a retail agency who gets it from a wholesaler, who gets it from a regional wholesaler, and any of these sources of supply can feed into what ultimately makes its way into my faucet or into my hose. Scenario number 2 is this guy. Much simpler. Or much more complicated because this guy doesn't have the ability for programming or funding that comes along with the relationships from that network. So that makes things a little more complicated for him. So this is, I'll share this slide. I'm not going to dive too much into it, but this is like a very simplified version of the dollar chain. So when you have to figure out, if you're a local retail agency, you've been tasked with saving 25% or cutting back 25% on your water intake, you have to figure out where you're going to get money to do all the things that you now have to do to try to save that water. So you can get some money from your wholesale agency sometimes because they will be getting money from way up there at the state level, and they can kind of funnel it to all of their member agencies. And sometimes you can have regional project agencies as well that are basically just a big board that sits around and distributes state money to people that need it or to agencies that need it. Oversimplification, but I'll share that slide so everybody can check that out. Any questions on that piece of it? That's like the dry part, so I apologize, but I wanted you guys to have some context of the overall shape of things here. Nothing? All right, so back here we go. So here is just a quick look at what that water storage and movement scenario looks like. I don't need to get into this too much, but basically what we've got here are a couple major aqueducts. So we've got Colorado River Aqueduct, which comes in just below LA and does actually supply a lot of water to Southern California. And then we have the State Water Project, which I believe is in the red here. And this actually isn't the greatest map, but believe it or not, I couldn't find another one. So we've got a couple of things represented by the different colors, which include dams, reservoirs. But really what I want you guys to focus on is these giant aqueducts, because that's how we move most of the water through the state.
Those aqueducts open, or are they closed?
Depends. But a lot of them are open. And they're having problems with them because of subsidence, right? Because a huge, what they kind of count on is that it's going to literally run downhill from Northern California to Southern California. So they have to raise parts of it. And it would be fine if the ground didn't keep sinking because they have to, every time that they can't force it to run downhill, they have to use energy to move it. So they want it to run downhill. All right. So what are the problems, what kind of problems could you guys foresee with that type of hierarchical organization when managing water supply? There's really one big one. There's many, but there's one big one, and I think as geography folks, you might pick up on it quickly. So water is a resource that's being managed by a bunch of agencies that all care about what's happening in their individual cities or towns. See where I'm going here? So there's no system in place to manage water as a resource the way water actually works, which is not only within your city boundaries, right? So having every single individual city and wholesale agency just manage a plan for their little piece of California doesn't work too well when they actually all have to be working together in some shape or form to manage a resource that's truly shared throughout most of the state. And I'm sure you guys have instances in GIS where you see the same kind of problem, things that don't compute with the sort of organizational boundaries that we place upon them.
So you mean efficiency problems, basically?
Well, efficiency, supply, and just general management. I mean, you have to agree on what the best way is to conserve. You have to agree on who has rights to which water, so downstream water. Is Timmy still offering the geopolitics of the Middle East? Has anybody taken that? Yeah, so did you read anything? Did you guys talk about water in the Middle East?
Yeah. I mean, yeah, we did a lot at the end of the semester. It was, especially now with the overpopulation problems.
Mm-hmm.
More and more issues.
Yeah. Yep.
Do you still have that slide of California right there with the aqueducts and stuff? Because that might help. I'm wondering.
Yep.
So you've got these different communities and that have all. How do they? I assume the community. I mean, they have different populations. They get different. I don't know, how do they get water allotted to them? It doesn't mean that they have water within the community so much, or the adequate water, but they're getting it from somewhere else. So they're taking it from another district or another community. It has to come from somewhere. So there's some inequities there, I think.
Well, yeah. And so actually for most of Southern California,
Right.
the water rights are managed by the one regional wholesaler, MWD. And so there's an article you guys will read tonight or tomorrow that talks about when MWD this year decided they were going to cut 15 I think they ended up deciding on 15%, but 10 to 20% of their supply. And everybody started to freak out because that meant they weren't going to get 10 to 20% of their supply. When MWD as an organization makes that decision, it means every single organization underneath them, hundreds of agencies literally, are also going to have their supply cut because they won't be able to import anymore. So some of the inequities, right? I mean, I've talked to people in Northern California who don't want to conserve at all. They say, we have groundwater. Why should I have to conserve? Southern Californians want to water their lawn. That's not my problem. There's a whole bunch of inequities in the way the current system is. If you were actually an agency that cared about efficiency and you encouraged your town to be very efficient, and there's ways that you can structure your pricing, which we'll talk about later in the class, that actually are based on your efficiency. So rather than just charging you on how much you use, you charge somebody on how efficient they are. So there are a couple of cities that are incredibly efficient. They were asked to cut just as much water as everybody else, and they said, wait, hold on a second. We've been efficient for 20 years, and now there's no credit being given for that. There's all kinds of things, and that's why that number that I pointed out in the beginning, the 400 water agencies, that's why it's so important, because every one of them is kind of like on their own little island with their own problems, and that's why this makes this such an interesting geospatial problem, because we have to tackle the issues of every single one of these stakeholders, if you will. So what I wanted to do was have a quick conversation about, now that we have a very vague picture of what that looks like, what do we think, knowing those stakeholders that we kind of listed out over there, what do we think, what factors might influence them, their actions, their interactions, and what variables, so when I came into this scenario as a technology company, what variables do I have to assess trying to understand how to respond to this drought situation? So let's think about what factors would these stakeholders consider when they're making their decisions about the drought? What things are motivating them?
Give us one example there.
Okay. Lost my chalk. So the first biggest motivator, easiest motivator, I don't think it's actually not the biggest.
Cost.
Cost is probably the biggest. So cost and budget, right? The first thing people want to think that it is conservation. And that would be great if everyone was just really motivated to save water. It's usually not the case, right? What other things might motivate people? These different parties. So we have the public, the private sector, we've got politicians, we've got individual governments, state governments. What sorts of other things do you think might be motivating factors for them?
Politicians.
Yeah. Go ahead.
Difficulty?
Achievability, yep. So, yeah.
Like, you can spray as much water as you want on your lawn, but it's got to be hand watering. Sort of thing. Nobody wants to do that.
Yep, fair, yep. Go ahead.
Things like public efficiency or
Very big one we didn't touch on yet, yes. So I like to call it public perception. What do you think the public, what things would you be afraid of? Public perception. Yeah.
Well, there's a problem of contrasting interest between the municipality of here and larger state representatives and stuff like that. For example, a mayor would be more interested in making sure his citizens get their citizens done. For really feel a difference, whereas a state level representative has to be more concerned with things like statistics and like how much we've improved this or whatever.
Absolutely.
And each of those are contrasting to what we like.
Absolutely. So I might classify that or kind of categorize that. Well, you could call it politics because it's just. I might actually call it, well, this isn't entirely fair. Let's put politics up here. But yes, and we'll consider politics competing interests, but this is what I really think that we get at if we were to consider that from many different angles. Competition and partnership. And we're going to talk a lot about that in the geospatial industry and in its partner industries. But so if you're a politician, you have certain alliances, partnerships, people that you've agreed to support, and you also have competition. The same is true if you're in the private sector. So when I came into this, I had to look at competition and partnership from a totally different perspective. So which water agencies did I want to partner with? Well, the forward-thinking, technology-friendly agencies were going to be my partners. And the folks that I had competing viewpoints with were going to be the ones who didn't want to change anything. And within my own market, I had to think about what other technologies were out there. Who could I partner with that would add something to my technology that made it more valuable, that I could then add something to theirs and make theirs more valuable? And who did I have to outright compete with, right? So competition and partnership is a big thing. What else? I might give you one because there's one it's probably after cost and budget, maybe actually a little bit bigger than budget, at least from the perspective of the water agencies, and that's regulatory compliance. And in a lot of the businesses that geospatial services work with, regulatory compliance is really important. Whether it's oil and gas, whether it's energy sustainability, you're always having to deal with the rules that the government made for you and what you have to do to essentially meet whatever standards they're putting forward for you.
Unless you're Volkswagen, then it doesn't matter.
Unless you're Volkswagen. Exactly. So regulatory compliance is actually, I would say, the single biggest motivator. And why do we think that is? Because there were some agencies, like I said, that were really working on conservation. They were mild and, some might even say, compared to the rest of the country, pretty heavy pushes for conservation in California until that executive mandate came down, and then people got really, really serious about it. So the regulatory compliance is really what kind of motivated everybody to kind of like have to get super serious about this. I'll add a couple more, but we talked a little bit about them. Legal, I don't know, so I'm just like, this isn't a great category title, but legal issues ties into regulatory compliance. Nobody wants to get taken to court and told that the way that they are charging people for water is unconstitutional, which is what happened in California this year. The water agency tried to charge people more in a very certain way, and they were told it was unconstitutional. So there's some very serious and real legal things that happen in a lot of these businesses. Politics we covered, but I want to talk a little bit about politics, not just for policy makers, but you started to hit on an important point here. Career politicians, why might they, I want to bring in the word risk, right? So every decision that people are making carries some kind of risk internally. So when I met with, I've met with Governor Brown's office a couple times on some of these issues after they issued this mandate. And the interesting thing was that they actually said, I said, we have this great way that we can help everybody achieve these savings. And they said, we don't really care that much about how it gets done, because our job is to mandate that it does get done, and that's where our job stops. There's too much risk for the governor's office to mandate how something gets done. That goes to another board or agency, right? It carries too much risk, and essentially what they need to do is make sure that somebody else carries the accountability. So it's like a transfer of accountability. And you see that all levels of business and government and all kinds of things. And your point about the public, if you're representing people in the public and they don't perceive what's happening to be fair and equitable, then you're going to be the one. So politics is also closely related, I would say, to, somebody kind of brought it up, but I'm going to add it here, media. So media has actually reported a couple really big things in the California drought incorrectly. and it's been very unfortunate. We'll talk a little bit about that, but the media can drive public perception and also political risk. The last thing, let's actually think about this just for a minute from the private sector perspective. So you're a technology, you're a geospatial consultant, you want to help people respond to this problem. What do you have to consider before you say, hey, I'm a geospatial consultant and I can map how this drought is playing out? What might you have to think about? Kind of goes into this competition factor here. It's going to be what we talk about later this week, and it's market. And with the market, we got to know what's the demand. We have to know our competitors, our available funds. So I want to make this point. The cost and budget of one of these stakeholders dictates the market demand for another. Okay, so the budget available to my customer, the water agency, is what dictates the demand for my product. If they don't have money for it, there's no demand, right? So just want to make that point about market. There's some other scientific variables we might have added up there, including things like weather. So weather's actually been a big factor lately. Everybody's saying, what about El Nino? And that actually can motivate people to not act for a period of time. So we consider some of these other things that that influence us. All right.
Ask tomorrow about El Nino perceptions.
Yep. Yeah, I mean, we can talk about it more, but so that's my little guy up in the corner that I focus a lot of anecdotes on, and he's like the neighbor Fred that everybody has that's always out watering their lawn, and this is like the big problem in Southern California. These are the things that kind of go through what we just talked about there. I guess the last one, we didn't get to this, technology and innovation. That's what we're here to talk about, right? So what's available is going to also dictate some of the response. So as we look at geospatial technologies, we're going to see that 10 years ago, the response would have been totally different because people weren't, it wasn't possible for them to send field teams out with a mobile phone and expect them to collect data from individual homes. So what's possible, what's being made possible by technology and innovation, both in the private and public sector, is really critical. And the other thing that we didn't really hit on was morality or equitability of response, and that's a huge issue in California. Agencies and individuals alike feel that, the response needs to be fair, and I need to know that, well, my neighbor's the guy that's out watering, it's not me. So there's this whole idea really driving everything about equitability. So I love this quote, and this is sort of where I transition to how do we solve all these problems. So I've just laid out a whole bunch of challenges, a whole bunch of different factors and actors. And so this is kind of what I'm hearing from a lot of my colleagues in the water industry, and they're saying, actually, this is kind of great because we have a chance to change things that have been static for a really long time in a slow-moving industry. So let's not waste this opportunity with the drought. It's pressuring us to make change. So and that's just a great thing. Anyone know Paul Romer? This quote. He's a professor from Stanford, and I guess he was quoted. He made this comment in a venture pitch 2004, talking about Chinese goods outselling Americans because Chinese are accelerating their education and training for their citizens. So anyway, good quote. So this is where we talk about solutions and how technology, data science, GIS can help us solve a problem. So this is the easy part for me. This is my company. I'm going to give you guys a brief overview of kind of what I do and where we come from. So we're a data science analytics company. And I say that very particularly because we actually sell data subscriptions. The way that you subscribe to Netflix, you would subscribe to our data sets. It's a very similar business model. And we'll hear more about that later this week. So I work with a lot of scientists. I'm not one of them, but I work with a lot of scientists, folks that have done a lot of physics, folks from NASA, Johns Hopkins, and we actually have two arms of the company. One is space satellite, and that division is working on launching a flock of satellites for 2017. So they are quite literally the rocket scientists in the group, and they are putting things in space, 2 years. The other side of the company is the data analytics division. That's where I work. And so we work with a cloud-based platform, some very cool data scientists, and a lot of business folks who are trying to get our solutions out into the public. So this is how we got into water. Because actually we're not a water company, right? We're a data science company. We had a customer and they gave us a bunch of aerial imagery and they asked us to do an analysis of the imagery. They said they wanted to know more about how efficient their service area was. So if you're a customer of any water agency in California, as long as you have a water meter, you get a bill every month. You get charged for however much water you use. So the agency knows how much you use. What don't they know? How much, what? How you use it, right. So they don't know the amount that you use. Is it being used efficiently? Is it being used well? So when we looked at that map from the New York Times and it compared each of these cities to an average, if that whole average skews high, as in wasteful, like we're using a lot, all it means is that you're using a little less than other people who are wasting more than they should. So what we really care about is knowing how much water you should use so that we can figure out where we can actually find water savings. So they came to us and they asked us for a bunch of things. And we said, well, how much water could you save if your service area was efficient? And they said, well, we don't know. And we started to realize that actually nobody in the state of California knows the answer to this question. If Californians maximize their water efficiency, how much water are they capable of saving? So the governor can mandate 25%, but we don't actually know if California is capable of saving 25%. We know how much Californians are using, but we don't actually know if they're capable of saving 25%. So that's where we came in. And what we offer as sort of a package, I'm just going to talk about the most basic thing that we do. Well, the first thing that we provide a water agency is called a water budget data set. And so what we do is we actually use satellite imagery. We do a land cover class. Are you guys familiar with this? Because we'll talk about it a little bit more, but so. So land cover classification is basically an analysis of the image that tells us exactly the square footage of trees, grass, shrubs, pools, man-made structures, impervious surfaces, all kinds of things, and tells us exactly how much of that is in each different home or parcel. We divide it by parcel boundaries, right? So in order to get a water budget, we start with a land cover class. We pull in two different data sets, weather and what we call evapotranspiration, or ET. That can go in our terminology list. And that tells us how much water the outdoor landscape needs on every single given day. So this, yep, go ahead.
So I've had a question in the back of my mind. Is like watering your lawn in Southern California in this drought crisis, is that still the prerogative of like the consumer, or because from a conservationalist perspective, it's like
stop watering your lawn. Yeah. It actually is. So again, it goes back to the agency. So depending on the city you live in, you may have rules imposed on you in terms of what you're allowed to water and for how often. And most of the time the rules are you can water only overnight on these 3 days a week. And if we catch you watering at a different time, then we'll give you a fine. A lot of cities don't have that at all. And so, it's still mostly up to the consumer. People are being encouraged to replace their lawns and get rid of grass. But yes, the easiest thing would be to say, okay, no more grass, Southern California, sorry. They're not doing that yet.
Is water metered in residential house, so they're paying for it?
Yes. Yeah. So residents do pay for their water. Yeah. Yep. Absolutely. So, but we come in with this budget piece before we talk about the meters, because what we want to know is how much water should this house use. Okay, so that's all we care about. We take a couple of different things into account. If we can figure out the number of people in the house, we'll take that into account. We use a standard number, but we also can do some frightening things with data science and kind of reverse engineer how many people we think are in the house. Yeah.
So the home park, is that kind of like what you assume people are using shower water and stuff like that too?
Yep. So the state has actually mandated what they call a standard, which they'll allocate. They'll say, We're going to put everybody at 55 gallons a day. And they assume every house has 3 people. And that's kind of how they equalize across the state when they're trying to determine usage and high and low and all that kind of stuff. So yes, yep, yeah.
How do you get that data? It's like man-made on these scrubs.
So that's the magic sauce. That's what we do. That is so cool and awesome. Now, a land cover classification is something you guys could do in ARC. You put in it's essentially a series of algorithms that's going to analyze 4-band imagery. So you guys are probably used to RGB, but we also need a 4th band. We need near infrared and NIR band. And we use those 4 bands, and we can basically tell from the different spectral signatures on the imagery what type of surface we're looking at. Okay? We can't tell very specific plant types without getting hyperspectral, many, many more bands, and Bill will talk about this in our lab looking out next week.
We'll do some of that in the lab too. Probably not as sophisticated. We'll do some of it. You'll get to see how this
Yeah.
works.
But when I'm selling this, I say that's the magic. We just press a button and it happens. It's not really true, but we've automated this whole thing. And what's so valuable about it is that we don't have to have a GIS person sit there and do it every single day, right? We do it automatically. And we are able that way with very heavy computational, we've got big servers in the back room that can crank through a lot of stuff. I mean, you guys know when you use ARC and you get the really sad skull face and the whole thing crashes and it's like the worst thing ever. We try to avoid having that happen for people. So that's the beauty of having this automated and having a tech company do it for you, is we can manage lots and lots and lots of data, and we can take into account things like cloud cover, sun angle, slope, atmospheric corrections in the individual kernels and pixels of the imagery. So we do all of that automatically, the automagicness, or so I say. So that's the first thing we provide, water budget. Water budget in your head, just remember, it's how much water should this home use, okay? How much water should it use? And
That's different for every home depending on the size of their lawn.
Definitely. It incorporates if they have a pool, if they have tree cover, if they have turf, no turf. And the reason I point this out, I'm not a scientist, but the very simple way to understand evapotranspiration, it's when you're looking straight down, how much water is evaporating from the surface of this parcel. So if there's a tree over the grass, we just care about how much is leaving the surface of the tree. That's how much water loss is happening on that given day. So here's what we do. This is the easy part. We pull in only 3 data sets. Parcel data you guys are familiar with, I'm sure. So that's basically, if we have anybody that hasn't had the full GIS experience, it's just the outline, the boundary of individual homes and businesses. We pull in the imagery, and then we pull in the water meter data. So the meter data is how much we actually use. How much water have we actually used? We run it through our magic sauce, which is a patented budgeting algorithms and other things. And what do we come out with? We come out with water budget by parcel, the square footage of irrigated area, which is really important to these guys, right? So for water agencies, they want to know, do I have a lot of people with really big yards? That's important for them because then they can focus their marketing on turf, for instance. And then the big thing, inefficient user identification. So I'm not going to focus too much on this, but because we just talked about it, but here's some examples of land cover. I like this one. It's pretty cool. The higher resolution your imagery is, the more accurate your imagery analysis is going to be. So, for instance, with agriculture, we're looking at giant fields. Oftentimes, we can use very high-res imagery. Doesn't look good at all to the naked eye, but we can still tell that that's alfalfa. So that's interesting. But for this kind of use, higher resolution gets us slightly better, more accurate information. We just talked about this a little bit. We run these efficiency calculations. So we do that land cover, we do the water budget, and what's important about the budget is that we're using state standards. So you brought up the indoor standard. There are other standards the state of California has mandated, basically the percentage of a gallon, really specific things. For what percentage of a gallon are you allowed to use on outdoor landscapes for commercial parcels? Only half of a gallon, as it turns out. So we automatically calculate all of that, which is great for an agency because going back to this idea of regulatory compliance, right? What motivates them to care about this is the fact that I can tell them that they are going to be compliant with all these state standards just by using this, right? This, however, is kind of the hot tamale It's the inefficient user identification. So we compare the budget, how much you should use, with the meter data, which is how much you're actually using, and what do we get? We get the difference. So if you've been using a whole lot of water for a long time, and as it turns out, you're just an overwaterer, we're going to see that because your usage is going to be way above your budget. So what that looks like in our platform is oftentimes a lot of homes that are highlighted in red. You'll see that tomorrow. And we're able to actually select that home and take a look at the actual usage and compare it to budget and look at their trend lines and things like that. So this is just a summary of those pieces. We're providing, again, remember I'm going to go back to, we're going to talk a little bit later this week about business models and this idea of a data subscription model, the same way you would subscribe to a Netflix or Spotify. These are the data sets that these agencies are subscribing to with my company or with our product. So they're subscribing to getting this land cover. They're going to have it automatically updated for them, the same way they're going to have these automatically updated water budgets to take into account the weather every single day. It's another picture of what it could look like, what it does look like. This is obviously some higher res imagery. We've got some blotchier information. And so what we call this whole thing, this whole package, is efficiency analysis. And this word efficiency has been very important for me, for our company, for actually positioning us in the market. It has made us friends and it has made us enemies. There are people who love efficiency and there are people who are not such big fans of efficiency. But essentially, efficiency analysis is doing this exact comparison of the budget, how much you should use, to how much you're actually using. Okay. Now I'm going to show you really quickly why this is important. This is a quick anecdote from Southern California. This is actual usage data. We got 4 homes, pretty similar. They all have yards. They've all got some trees. They all happen to have 2 people in them. I know this because this top house is actually the general manager of a water agency. And when we look at his actual usage, it's pretty low. Good job. 75 GPCD. That's actually really low for 2 people.
You probably went,
Yeah. Well, I have another story about that, but yeah. So we've got his 3 neighbors with varying levels of water use. Obviously, this guy here in the middle, number 3, he's the bad guy. He's using a lot, or is he the bad guy? Right? We don't really know. If his mother-in-law moved in and he's got 5 extra people in the house, maybe that's not so bad. This is why budgeting is really important. So what's being done currently in California is they're saying, all right, we have to cut back water, so get the messengers out into the streets. Everybody needs to cut back water. 30%, cut back your usage. So in that scenario, if each of these homes were to cut 30%, these are the savings they'd be looking at, and this is, again, GPCD, gallons per capita daily. That's the potential savings we, the agency or the city, could get from these 4 homes. What are the problems with this? Anybody? Yeah, go ahead.
Well, person number 1 is already using a very low amount of water, so it's not
Right. So person number 1, it's not fair to ask him to cut 30%, but even go further than that. Not only is it not fair, if he's already really efficient, it could be impossible. Right. We're probably not going to get this 22 GPCD. Anything else? Yeah.
Well, it doesn't make sense when you have someone who's using way too much water, they could cut like even 50% and you're gonna save a lot more than
Definitely. Yeah. So that's the point. We could ask guy number 3, house number 3, to cut 50%, and we'd maybe get a lot more water. Now, what does that mean for me as a water agency? I'm going to tell you. With these 4 houses, if I want all of them to cut 30%, I need to pay for outreach to all 4 houses. Whether that's flyers, whether that's ads, whether that's knocking on their door, it's going to cost me a certain amount to conduct outreach to all 4 of these consumers, 100% of my consumers. So I'm going to sleep. So here's the other method, right? This is efficiency analysis. With a budget, we can see in this particular case, all 4 of these homes are in pretty similar need categories. We've got a little bit of variation because we have a pool in that last house.
that's what drives it, 85 gallons.
Right. So now here's what we see. If we ask them to cut to efficiency, saying we need you to be at this budget, we've got that, again, we've got the 3rd house here could cut, is capable of cutting 158 gallons per capita daily because they're just highly, highly inefficient. So that means a couple of things. First of all, the potential savings is way higher if we were to go after all 100% of these guys. Second of all, if we wanted really cost-effective outreach, we would want to just get in touch with 25% of the consumers that we've identified specifically as being capable of saving water. Okay? Any questions on that? This is just a same picture, but a little bit condensed. Yeah.
What kind of assumptions are you making about like the, I don't know, integrity of the water infrastructure in like each household or in like the area? Is that standardized or is that like?
When you
you
say
have that
integrity,
data?
what do you mean?
Just as like, do the pipes leak in specific houses, or do you know these things, or do you have data on like these neighborhoods that we know are like, you know, these pipes lose like 20% of their water? Like, do you have that data?
So what you're talking about is actually another product, because what do I want to do as a data company? I want to say, oh, this guy for the last 8 months has been using the same amount of water, and all of a sudden his water spiked. We would automatically flag that as a leak, potential leak, or a mother-in-law has moved in, right? One of the two scenarios. The other thing that can happen is his water drops to 0. Now that could be a vacation home, but in the middle of the country, what tends to happen where people aren't focused on conservation as much is that would get flagged for theft. So somebody taps into the water line before the meter, and all of a sudden they stop using water, or their water use goes to like 10 gallons or something really, really silly. So yes, you're absolutely right on. We can track these data patterns in a lot of different ways. That information is really valuable to the retail agency. Yeah, but we can't guarantee that there's not a leak. But that's one of the things we can help them find, and find faster. So I was laughing when you said this about the general manager. It's a good thing that he went, well, we just delivered this product to a small agency out in the middle of the desert near Palm Springs. And I sat down with their general manager a couple weeks ago, and he said, you know, you just delivered me this thing, and I logged in, and my house was bright red. And I thought, well, and he was just like, I thought you guys were basically full of shit, and you didn't know what you were doing. Because, like, I know I'm an efficient user, and how is this possible? Well, it turned out his water rate had been essentially static, because he's the GM, and he was in some paid water rate structure where it wasn't going to change no matter what his usage was. And last month, he sprung a leak. He wasn't aware of it because his bill was the same. He doesn't have to pay a higher bill. And so he actually didn't know that he had a leak until we flagged that he was being highly inefficient, was way over budget. So he was a GM, and he's paying attention to this stuff, but he still missed it. So that's how data and watching data and being able to have kind of flags on data can highlight problems that are harder to find on the ground. Any other questions on that piece? All right, rounding the bend here. Okay, so this is the last little graph. This took me a little while to wrap my head around at first, but now it's one of my favorite nerdy graphs. What this shows is how much water customers in a particular city are using. This is actually the city of Folsom. And what we have here is a pretty even split, where 0 is people that are using right on their budget. So people that are pretty efficient. They're using about as much as they should use. People in orange are using X amount more than they should use, or are a certain amount of inefficient. People to the left of the line in the green are using less than they should, and so they're doing great. They're under budget. And so what this allowed us to show this particular city was how much water they were capable of saving. So I'm going back to that first question. How much water are you capable of saving? They had a mandate from the state to save 28%. And we came in and we measured all this, and we were able to say, listen, if you got 100% of these inefficient users to 0, right to budget, I'm using exactly as much as I should and no more, you can save 15%. So what does that mean for you if you have to save 28%? So what I like to think of when I look at this is that this helps us measure for the agency the level of pain associated with meeting these mandates. And so your earlier comment about difficulty is an interesting one, because the level of difficulty, and we're talking about equitability again, so for some cities, the level of difficulty or achievability, how hard this is going to be, varies, truly does vary. But this is important because it's the first time that this city had any idea what their actual capability to accomplish this was.
Plus, in there, there's, I'm sure, low-lying fruit,
Mm-hmm.
things that you can bring down very quickly.
Mm-hmm.
But that last 5 or 10 or 15%
Could be brutal.
could be brutal.
Or what you do is you say, okay, how many people do I have to get to remove their lawns? What square footage of turf do I have to get removed in my service area in the next year to be able to meet that 28% mandate? The important thing here is that we can measure it. When we know this number, we can actually come back and we can say, I need X amount of square footage of grass to be gone because I got to get to here, right? I've got to get these budgets way down. So that's just an important thing that we were able to deliver to them. And similarly, that was the who or where do I find these savings? This is the when. This is kind of common knowledge amongst water conservation directors that summer comes, people turn up their sprinklers, and when the fall comes, they don't readjust fast enough with the weather. And so they see that there's a lot of waste in water that happens late in the summer and into the early fall. But this is the first time we were able to quantify that, where we were able to graph budget against usage. And what's actually really interesting about this is that there's times of the year where people are like under budget and they're not struggling with it. But there's solid times of the year where they're really overcompensating because they're still in this summer mindset. So a lot of it comes back to like social behavior. And this was just, again, first time we're able to quantify exactly how much water they're losing during this time of year so that they can start to think about, when do I do my marketing to these people? Oh, guess what? I'm going to do it right here, right before that peak and drop comes, because I know I'm losing a certain amount of water that I could be saving at that time of year. Any questions on that? All right, so this is more of like a reference slide for you guys to look at if you're kind of trying to piece all this together. But to summarize efficiency-based technology, the first big thing, we're helping people save water because we can calculate the potential savings. So we're finding where it's possible to save that water. And number two, we're responding to regulation, which is a huge driver. And we're measuring the achievability or the difficulty of reaching those state conservation targets. We're allowing for cost-effective public marketing campaigns. So targeted outreach is huge. Instead of sending everyone a pamphlet for your turf rebate program, how about you only send it to the people who actually have lawns, right? You don't know that if you're a water agency unless you have this kind of data. Fair and equitable. This is probably the thing that appealed to me the most when I started working on water budgets, was that it takes your individual circumstances into account pretty nicely. So when I talk to agencies in Northern California and they say, oh, well, we're not the same. We have different weather. I know, we account for that. Well, I'm not the same. My neighbor, he has a pool and 5 kids. I'm like, I know, we count that too. So the nice thing about water budgets, they're very individualized, and therefore I think they're pretty fair and equitable. Technology makes it possible. So this is going to that last sort of driver that we talked about, stakeholders and what motivates them. If we didn't have the kind of not only data science, but servers, computational servers and cloud-based technologies that could do this kind of computation on a daily basis, then we're back to what a lot of water agencies do right now, which is they do this, once a year. They come up with a general, ballpark estimate of what they think they should be using. And a lot of times they do it with a GIS tech who has to sit there for like a month and try to slog through all this analysis. And the last thing that I love, and this is really my dig at some of our competition, but is that there's no ceiling on achievable savings. So a lot of drought tools that are out there to encourage people to use less water are very focused on conservation in the sense that they're going to compare you to your neighbor and say, you could use less. But what they found is social behavior only motivates people to save about 2 to 3%, which was great 5 years ago. But right now, you need to identify people that very clearly could save 20, 50, 100%. So there's no ceiling on the achievable savings. It's just about figuring out how much savings are out there. Okay, so this is one of my favorite things to talk about. So we talked about the problem, talked about the stakeholders, what motivates them, and we've talked about one solution, which is the one I'm the most familiar with. And you think, okay, so I think water budgets sound pretty viable. So if I come to you and you're a water agency, what are all the things that you're going to tell me are reasons why you think this is actually a terrible idea? And this is just to give you guys a sense of what you encounter in business, and sort of, color things a little bit with, again, going back to those different motivations. So what do you guys think people might oppose in this scenario? Anything? Yeah.
Like outreach can be like 100% effective.
Mm-hmm.
Like if you're sending a flyer to the household saying, reduce your water usage, like you don't know if they actually use it.
Yep. Yeah, we get a lot of that. It's opt-in. They can choose not to do it. We've been mailing them for 10 years. So who cares? Yeah, absolutely. Yes.
It's still expensive. Like, there's risk of expense.
Yeah, literally any dollars at all are frightening to some people. I mean, I don't know if you saw that in the municipal market, but it depends what market you're in. The market that we're talking about right now is very tight on dollars, and if they don't have a budget for it, it's definitely going to come. You're going to hear about it. Anybody else? Yeah.
What if my customers find out I'm using this kind of invasive software?
Invasive. That's one of my favorites. Yeah. So what do you think people wouldn't like about it?
Software figures out things about their home, things about their family.
Absolutely. I hit that. I do run into that
Yeah.
a lot. Yeah.
That's a good one.
It's a very big one. Yeah. Anything else? Okay, I'm going to run through a list. So there are some people that are opposed to this because they have been opposed to efficiency analysis for a long time, and it wasn't as relevant 10 years ago as it is now. But they have made their camp, and they're going to, stick with it. So that's one thing. Individual water allocations are threatening. I like the word invasive better. That's a much better way. But yeah, both agencies and consumers very concerned about having the government tell them how much water they should use. That's a pretty scary thing. Yeah.
You're going to get, inherently, I think you're going to get some mistakes here and there, and therefore you're going to have an actual human going in, and that's going to be expensive because the human's going to have to actually visit people's house and determine, it turns out you actually don't have water, you do have,
Yeah. Yeah, absolutely. I don't even have that on the list, but that's
or you do have 5 cousins living with you.
Yeah,
Right.
that would be really
That's
interesting to see what the accuracy is of this.
yeah. No, accuracy is a big thing, and I should have thought of that. We do ground truthing, and we guarantee to a certain point of accuracy, which actually is around, depending on the resolution of your satellite imagery, it's around 96%. It's pretty damn good. Yeah. But that being said, you're still going to have, the imagery was taken 2 months ago. I ripped my lawn out since then. My response to that is usually, well, if the person ripped out their lawn and their water budget's higher than it should be, then they're not the person that you need to worry about anyway. And if they replaced their lawn in the last 2 months with new grass, and they're saying, why is my water budget so low? I just put in a new lawn. Well, then there's still a person you should probably talk to. So from an outreach standpoint, it kind of, balances itself out. But accuracy of data is something people get very, very hung up about.
I
Yeah.
assume you're beholden to be using some of the records from the municipality on water use. And,
Yeah.
You're assuming that those are all accurate.
Mm-hmm. Yep, so we import their meter data. We provide the parcels and we provide the imagery, but we use their meter data, which can be in the form of a PDF, literally, with some of these small guys. They may have complete holes, missing data. I mean, just miserable problems with data, absolutely. Costs, we've talked about. There's no money. The public won't accept it. Various reasons the public might not accept it. Invasive is one, but there are others. Associated with legal complexity. This is one that doesn't get talked about a ton because it's sort of like accepted in California, but there was this big court case over the summer. We actually will have a guy speaking with us later in the month that will talk a little bit about that. But yeah, legal complexity, fear of being sued, fear of having, am I using this data appropriately? That's a scary thing. Then it's too complex. I don't have the staff. I don't have the time to implement a new software. It's going to be confusing. And when I do have the time, this is a big one too. I've already got an IT guy and he wants to build this in-house. It's literally my least favorite thing to hear, but I hear it all the time. And I can guarantee that one IT guy is going to spend 2 years building this, and then it's going to be out of date, and he can't maintain it with the single desktop computer, but it's threatening to have an outside company come in sometimes and kind of, shape how you're running your business. So that I absolutely understand. Then there's just a marketing piece for challenge for all companies, differentiating yourself so that they don't think they're the only ones. You're the only ones that can do this. And this is my favorite. I get this sometimes. So water conservation director that I met with early on in this process, third largest city in California. I won't name names. And he said to me, it might rain. I'm not going to do anything yet. So that's a little scary. Yep. So that's a list of the things that we get in response. I know we're over time. What I wanted to finish with was just that this list of the stakeholder considerations that we have come up with for water is going to apply to all of the things that we're going to discuss. So when we talk about conservation, let's just make that environmental sustainability, regulatory compliance, all of these things that we talked about in terms of water are actually very relevant, and we can just change that to defining factors in geospatial product development. So we're going to return to all of these sort of linchpin tenets throughout the course, and we'll talk about the legality, the morality, the political piece. This week particularly, we're going to talk a lot about market demand and sort of how we get a business and a product up and running. But I think that's good enough for today.
That's all we got.
That's what we got.
That's all the time we got.
Yes.
Let's see tomorrow. 1, right?
1 p.m. Yep.
Upstairs in 319.
Thank you, everyone. Have a good night.
Okay. See, there's always more than you think.
You're right, Bill. I know. You're right. That's actually comforting, though.
Yeah.